All right, so our next presenter is Steve Umbehocker. Sorry, I hope I didn't slaughter your name. He's the CEO of OS Nexus, and this is going to be his 5th OpenZFS Developer Summit. So today he's going to be talking a little bit about the ZFS work which is being done at OS Nexus, give a little overview on some of the topics. So yeah, please welcome Steve, yeah.
Thanks. I've got a presentation today on a tool that we've developed to kind of help people build better ZFS solutions at scale. So for companies that are building stuff that are at the rack scale, for many years, we just designed everything in Visio. So you'd get to be able to see the whole solution, and then the end user and the distributor and everybody could go and take a look at a picture of what they were going to go deploy. But that had a lot of problems with it. One of them is that it's really collaborative, working with the hardware supplier and the customer and figuring out, hey, what's the right build? And if they go and they change one thing, then it changes usable capacity and all these different factors. So we wanted a way to kind of eliminate Visio from the equation and to just make it a lot easier to come up with something in minutes rather than having somebody have to use those tools. So that's where kind of made a big list of things that was like, how do we get rid of Visio out of this equation and just make it turnkey? So it needed to be some way where it would be a web app, but also that people could just go and share their designs with each other. And it needed to cover our hardware compatibility list. And our HCL is basically every major vendor that's out there. We work with all the major vendors from Dell to HP to Western Digital and others to go and certify Quantastore with the ZFS build and do all the HA failover certification testing. And so that's where this came about. So I got some help getting this started, and I've been hacking on this utility for better part of a year now. And it does all the math, and what that means is that as you increase the size, it increases the number of drives in increments of the VDEVs. It lets you choose the number of JBODs, but it also kind of makes it easier for the end user. There's a lot of knowledge here that we all just take for granted using ZFS for so many years. Oh, yeah, there we go. And so I was trying to just get a lot of that knowledge into the tool so that more and more people could be successful in deploying ZFS solutions and take a lot of the mystery and fear out of it. And so there's a kind of the two main things is right as I jump in, I'll show you a demo of the tool here in a minute, is that you can choose a use case and you can choose a capacity, and it will automatically choose a lot of good recommendations for that given use case. We put all the tools online, and there's no login required, so you can go to the tool, just osnexus.com/ZFS designer, and that'll take you right to the page. So this is sort of like an example. Like, customer comes in, say they're an HP shop, they're looking to use more HP gear, and so what the design tool lets you do, and I'll kind of jump to that here if I can. I already had the browser up, but I think it's behind here. There we go. Okay. Oh, yeah, I got it. Thanks. Cool. Can you make it large? Yeah. Oh, awesome. All right. And I think I can probably zoom in a little bit. It's kind of an eye chart, but there we go. Can you guys see that pretty well? So now, no more Visio. When a customer wants to go and try, they change their mind, or end user wants to change their mind on, hey, I need more or less storage, they can just start adjusting with the slider bar, right? So everybody can adjust the slider bar to go meet whatever capacity they need. And then a lot of the common use cases, like say they want to do triple parity, like for a cold archive, they can now just start putting those things in there and adjusting it. So all all the servers that we go and test ZFS with and do the HA failover testing are all in here. So you can just pick a different server or pick a different JBOD and put it all together. Here's like the Seagate, their 106 bays. And then as you adjust the capacity, it just starts adjusting the design. It's going in these big increments because we've got this set to maximum or minimum of 4 JBODs, but you can just kind of give it the full range, and then it will go and adjust that. In QuantaStore, we automatically detect the JBODs and do a lot of hardware integration to show it in the UI, and we stripe across the JBODs for fault tolerance. So if you lose a JBOD, you won't have any downtime to the pool. And so some of these settings, like the large-scale cold archive, automatically pick the minimum number of JBODs to go and match that. So some of the other things is, let's say your system integrator, they tell you it's going to cost X amount per server or X amount per drive. You can start to put that data right in here, and then as you move the slider and adjust things, it goes and does all the math to tell you what the price per terabyte for the hardware is. So it makes it real easy for them to figure out, okay, as I scale, what does this look like? And as you can imagine, if you're doing a really small pool with a lot of hardware, the price per terabyte for your hardware is a lot higher than as you start getting out to scale. This bit here, the RAM capacity ratio, this is, as you increase the size of these systems, the build of the server config is dynamic. It starts to add more and more to the box and more RAM. In some cases, it can be a little bit kind of extreme in that you're putting too much RAM into the box for a given archive use case. And so this lets you kind of adjust that by being a ratio in terms of gigabytes of RAM to terabytes of capacity. And this last bit here, this is where you get to choose like different RAID Z levels. This is all data driven from a JSON and stuff like that we put up into the Amazon cloud, so the app just sort of dynamically loads everything. But we're looking at putting in some sliders here so that you can just choose the number of data drives and the parity between a range of 1 to 3, so that it's not just the fixed values, but like here you can pick 9 plus 3, and then you're still fault tolerant across 4 JBODs. And then these last bits are for reserving some drive slots in case they want to grow by expanding, by adding drives, and reserving some disk space so that you don't go beyond that 80 to 90% limit, and that you're accounting for that in the design of the build. And so yeah, this utility has just basically eliminated about 95% of all the Visio work that we do, and it just saves a huge amount of time. So now you can kind of think about different ideas and run them by the end user or system integrator. And what you can't see here is at the very top inside of the browser window is a URL that has all of this data in it. So you can just take the URL from this and email it to somebody and say, what do you think of that? And then they can adjust it and send it back to you. So there's no files to have to save. It's all just straight in the URL. Which takes me back to the slides. Yeah, I think I can just hit the button there. It should take us back.
Yeah, I think so.
Thanks. Cool. So kind of futures for this is, well, before that, so the tool really helps eliminate a lot of these Franken builds. It's terrible when you see someone using a consumer grade SSD for just about for anything, and it's unfortunate sometimes where in HA configurations, of course, everything's got to be SAS, and you want it to be SAS anyways. This just starts to put them on the right path. So the design tool doesn't let you pick bad choices in terms of drive types. So a lot of these problems have just sort of go away as long as we've got a design that's within the tool. And then, so where are we going with it? So performance is sort of the next phase of this is how do we go and quantify the performance as you go and start adding more and more hardware to a build, and your goal is to get to 10 gigabytes per second. Where do you stop? Do I need to buy a gazillion dollars worth of hardware, or can I stop when I've got 4 servers and 4 pools? And so what we're working on next is to make some tools to quantify sequential performance and IOPS, and then start putting that into a database that can then let us start building some equations. So the goal is to start getting synthetic benchmarks out of running tests on enough different systems that are similar that we can start to say, okay, if you take a RAID Z2 4+2 and then start expanding it out, it's going to work like this. And we take a best fit line through several of the major vendors and then call it that. So now, you know, somebody that doesn't have a lot of ZFS skills but wants to start using ZFS at scale for a given use case, whether it might be a university or a healthcare institution, they can start to do that and not have to really go run their own performance tests and stuff like that. It's not going to, performance testing is a black hole. I mean, when you get down into it, there's so many different parameters, but what we're looking for is to have it land somewhere in the ballpark so that they have a starting point that's going to get them something that's within the right parameters for their needs and use case. So kind of futures was that performance stuff. Really looking for a lot of feedback on what would be the right group of tests, trying to keep that group of performance tests down to like just a handful of FIO runs of maybe 6 things to just try to capture a bit of IOPS and a bit of sequential performance for the most kind of common cases there. And then other things that we don't have are some little things in the utility, like showing, hey, please reserve a spare per JBOD, and showing the cabling diagrams. And some of these, like the cabling diagrams we put on our wiki pages, but those things kind of getting tied into the tools are just going to make it that much easier for everybody to see, okay, I'm going to buy this, it's going to get cabled like that. There's no mystery to it. So we're going to open source the utility as well and put it on GitHub. It's not out there yet, but I'm trying to refactor the code. I'm not real proud of it. I'm not a JavaScript guy, but trying to make it a little cleaner before we put it out there. Yeah, so that's it. Any questions? Yeah.
Is it all written in normal JavaScript, or is it all TypeScript?
It's all just vanilla JavaScript. It's actually not too much code, and I've been just sort of trying to refactor it a little bit so it's a bit more readable. I had some help. I hired out the kind of the starter seed at of that project, and then kind of took it over about a year ago and just been hacking away at it here and there. But yeah, it's really vanilla JavaScript. And I actually think that at some point or another, when it starts getting like multi-tabbed and all that, maybe it needs a rewrite, but it's saving a huge amount of time so far. Yeah. Yeah.
Do you have any models about data durability versus like CDS and drive environments?
We don't today. We capture a lot of logs that give us everything from smart information and things like that, and it lets us kind of analyze the configurations that are out in the field and see when people have like misconfigured things, like set it to sync disabled or something like that for a test, and then they forget to turn it back to sync standard before production. We've seen that happen before, but no, we don't have like the Backblaze type analysis of the drive endurance and MTBF stuff. Yeah. Yeah. It doesn't, but that's a great idea. I have to chat with you afterwards, and that would be a good thing to have. It does have in there a let's see if I can get back to it. It's got a thing where you can indicate how much you expect is going to be the overhead, so you can start to reserve some extra. So if you think that there's going to be a lot of padding happening, so you're going to get a lot of wasted space, then you want to overbuild the config by X%. So there's a little slider where you can say I want X amount of additional space. Yeah, it's in the browser. There we go. Thanks. Yeah. So that bit there on the reserve free space lets you just kind of adjust that based off of what you think you're going to need extra for padding. And the reserved drive slots is more for kind of making the hardware configuration bigger intentionally, because if you reserve a bunch of drive slots, it's going to need to add more and more kit. But that might be intentional. Maybe the users got all the hardware up front and they want to just add drives to an existing configuration. They can just do that. We constantly add to the backend database for this new hardware. So as Seagate and Western Digital and all the major manufacturers come out with their new JBODs, those are going into the tool pretty quickly, and we so we do our best to keep up with all of that. Yeah, and these here, in order to see like the information on the estimated price per terabyte on the hardware, you've got to go and put in some numbers here, otherwise you won't see those calculations. So the NA that you see down there in the bottom is going to start to show now. So like this build here, you can see the price per terabyte comes out to like $44, and that's because we've got and not so optimal here. You see it come down to 39. This was an eye opener in terms of price per terabyte on the hardware. I don't know if you guys track it closely, but the price per terabyte right now, street price, is about $25. And so price for a petabyte of just the drives is about $25,000. So sort of all in for a hardware for a petabyte of storage, it's less than $40,000 today. It's more like around 35. And then you factor in distributor stuff. It's all different. But it's pretty incredible. And next year, the 18 terabyte drives are going to come out. That's going to provide further downward pressure. You're going to see $30,000 a petabyte in 2020. So that's going to be great. We do a little bit of work on shingled magnetic recording drives. Those aren't ready really for prime time. We've done some tests with that with ZFS, but we haven't trouble like expanding the pools. Wasn't absorbing those drives in, but you could create one. So we're doing work there. We're doing a lot of work on NVMe, and that's one other kind of interesting thing in the tool is if you choose this Western Digital server here, that is they have a box that has 2 blades interior. That's actually 2 servers right there with all NVMe drives. So we've been doing a lot of work with Western Digital. That's a fantastic unit. And they kind of designed that all NVMe box as something for just doing high performance virtualization. But actually as a high density box, it's fantastic because you get these 24 bays of all dual ported NVMe that we can use in a high availability configuration. And so that means that we've got lots of slots to use for slog and L2ARC and the metadata offload. And really, we're most excited about the metadata offload because that's just going to have a huge impact on the RAID Z sequential throughput. So, yeah. Yeah, the DRAID, this was something I just wanted to make a contribution to last year because you guys had some discussion about DRAID. And what I want to do with the DRAID map calculator is make it so that you can say these groups of drives are in this, sort of make subgroups of the drives. So you can say each of those JBODs represents, so you've got 4 groups, and now the DRAID can stripe across those knowing that it needs to make the sort of the mini RAID Z stripes on the interior fault tolerant across the JBODs. It doesn't do that today. But once we do that, then we'll look at adding DRAID into Quantistore and doing that. But and then we can add it to the storage layouts. But we just have to experiment with it some more. Yeah. Yeah. Yeah, it just, the thing of it is that the skill set at the resellers and distributors for software-defined storage generally goes down year over year. There's much more specialization, and so what this does is it just empowers all of those folks to really start doing design. We review it and everything, but it just lets the conversations just flow much more freely, because there's no more Visio. Nobody has to have Visio installed, and they get to see exactly what they're getting and exactly what's in the hardware build. We don't sell any hardware, so this was just sort of like eliminating that barrier to, essentially enabling the users to kind of do a lot on their own. So it has been transformative, and it's just been just a big win the whole way around. Yeah. All right. Any other questions? Cool. Thanks.